for the feedback, like it helps. So thanks also for the patient. Okay, so nice, great to hear, fantastic. Thanks guys for the feedback. Uh, so does it make sense? Yes, it makes sense because it's very difficult to counterfeit the information, and this makes it possible that there is a unique truth, no? So this is also the question, no? When is blockchain needed? Like, because we said it's very inefficient, is slow, so but also it gives a verifiable truth. So it's sometimes you use it, sometimes not, no? And at the end, we need it when there are several parties, no, with different or opposite objectives, no. So blockchain in this case allow all these kind of parties to interact, no, between each other and without relying on an intermediary, and still, no, ensuring that there is trust in the system. And so blockchain, for example, can be needed in markets where some intermediaries cannot be trusted, no, or is too risky to trust because the stake is too high. So it also is used when is needed an immutable source of information, no, and that cannot be changed. So at the end, there is kind of a shift in a paradigm that is from the paradigm that is, okay, I trust you, you trust him, so I trust him too, no? So what happens in this fiduciary system that we have, economic-wise, and to another paradigm that is, okay, let's do like this. Nobody trusts anybody, no? And this is why everybody trusts the system. Why? Well, because if nobody trusts anybody, then what happens is that everybody has an incentive to control the others, to make sure that the others are not cheating. Exactly because like nobody trusts each other, so we all need to trust the system. And so the system gets trust because of this lack of trust in the people participating in the system. So this is the counterintuitive in a sense, but this is the power of blockchain. It starts with the assumption that nobody can be trusted, which is now kind of different of the system we see now. So we can see now a small analogy, no, to understand this, that it is okay. Let's assume, no, that there is a bunch of people, like you know, in a society, and everybody has their own book, no, of truth. Like everybody has their own version of reality. They have an opinion about it. The problem, no, if everybody has their own reality, is who do you trust? Because some of them can cheat on you. Some of them maybe don't want to cheat on you, but maybe they just didn't see all that happened in the reality. So still you cannot trust somebody that has a partial vision of reality. No? So wow, how can we fix this? Well, the answer is simple. Like we get a guy in the center, no? A central identity that has all the truth, no? All this book we give to him. We trust this guy to handle the truth, to handle this book, and we trust this guy to write whatever happens, no? So what's the purpose of this? Well, the purpose is if this guy is trustworthy, no, the fact that he has access to the whole information and he's the only one who can write in this book what happens and what does not happen, well, at the end the system works, no? Because everybody trusts him, he's a good guy, he writes everything, he knows everything, that's perfect, no? And that is how centralized entity works, and this is also the reason why they are so efficient, because it's easy, no? You get a book, there is a guy just one guy who manages it, and perfect, like everything is smooth, no? Yes, but what happens if this guy that has the access on the book and is the only guy who can manage it, the information on it, well, what happens if this guy cannot be trusted, no? And sometimes we see, and this is also a problem that we witness, no, in different spaces. Well, for him, it's perfect because he's the only one who has access to this book, so he can counterfeit it however he wants, and it's very difficult for everybody to control what he's doing because he's the only one who has access to it. and it's impossible for the network to say, hey, you're cheating, because is the holder of the truth. Like, how can you accuse him of cheating? Like, is the guy who's managing everything. So this is a problem. And this is the reason then blockchain comes in. And sorry, I come back again to the previous slide, because there is a thing also to understand, that this guy, if this guy changes the last page of the book with saying, okay, let's see, Luca owns now €0, let's say, no? Because he write in the last page, Luca now owns €0. Well, this guy has the truth, this guy has the book, the last page of the book is the last page of the history, no? That has been written. And if there is written that Luca has €0, well, Luca has €0, owns €0. This is a no-brainer, no? So it's very easy for him just to get a pen, and with just writing something in the last page of the book, he can modify everything in the whole history of the book, no? Just it's an entry in a database. You modify the database, poof, it's gone. Well, in the blockchain, what happens is there is a book in the middle of the table. Everybody has access to this book. Everybody can write on it, and nobody trusts each other. So everybody is gonna look and is gonna be very careful of what the others write, because we all have a common book. We don't trust each other, and this is the book that allow us to interact between us. So we really need to be very careful on what the others write. So if somebody is cheating, well, the others can see it. Why? Because he wrote something in the middle of everything, and everybody can say, hey man, like, what are you doing? Like, get out, no? It's don't make a mess out of it. So there isn't anybody who controls the book. Everybody can write on it if they write something that is current with the history of the network. And this makes that everything is more transparent, and it's more secure, no, in a sense. So we said already that this guy in the centralized system, like, he can just write something on the last page and all the history it's erased in a sense, no? He just puts something in a database and everything is gone, or everything is modified. And this is also a problem, because it's not just that this guy can be evil. Maybe this guy is just stupid, or maybe he's just ingenious, and maybe there is an hacker that is very good and he gets into the database and he destroys the database, and then all the history is gone. Like, it's, wow, this is dangerous. So it doesn't need to be this guy evil to cause us problems. He can also be an evil attacker that introduce himself in the system, no? In blockchain, no? Why is so incredibly transparent and secure and whatever? Well, the reason is that if you want to modify the last page of the book, let's say like this. Let's say last year I worked, no? And I don't know, I gained €1,000. And I gained this money last year. And today I want to give it to somebody else. No, I make a transference and I give this €1,000 to somebody else. Well, while in a centralized system, like, somebody could write in the database, Luca now has €0, he owns €0. In blockchain is a little bit more difficult, because what happens is you will need to convince everybody who is looking at the book in the center of the table about every page that has been written since the page that I received €1,000. So what I mean is you have to convince the whole network that is witnessing what's happening, no, the book, and convince them that every page since the page that I received €1,000 until the page of now where I give this €1,000 to somebody else, well, all this lapse of time, which in this case is 1 year but can be more, well, you have to convince page by page everybody who is witnessing, who is seeing the book that I have the truth, no? Well, it's a little bit more difficult, no? As you can see, and this is made because every page is linked between each other. So every page is seen by everybody in the network, and every page is connected to the previous one through a cryptographic link. So this is what makes everything so connected, and this is the reason why it's not easy to cheat on blockchain, simply because you need to convince everybody in every point of history that you have another truth that is the truth, the real one, no? Let's say. So this is what makes blockchain so powerful. So at the end, this is what we talk about. Like each page of the book, is connected to the previous one, and everybody collaborates, cooperates to write the book. So this is the reason why there isn't anybody who is in charge of the book. So now we talk a bit high level, which is always good because it makes the brain think a bit. And now let's go a little bit on how this is obtained, so who are these people, who look at the book? Well, these people are called nodes, and a node means simply it's somebody who has a computer that downloaded the software of a specific blockchain. For example, I can be a Bitcoin node if I download the Bitcoin software. I do it, perfect, it's on my computer. Well, I'm a node. Well, what does it mean? Well, I'm part of the network, and since I'm part of the network, I have the opportunity to validate what other people are saying and what is happening, and also to broadcast the information that I receive from other nodes, from other people who downloaded the software in their computer, and through gossiping, talking, blah blah blah, with other computers. Well, I broadcast this information, and why you need to do it in the first place? Like, I really don't want to download anything. Well, no problem, but like some people do it because they get rewarded for it. Because if you spend some resources, which depending on which resource, is it depending, on the network, the resource can be different. What you spend to be able to validate the network. Well, if you do this thing, if you take this risk to say your opinion about the truth, and you waste something that can be your credibility, can be electrical energy, can be money, whatever. Well, the network rewards you. How? Cryptocurrency. So this reward is what makes possible a peer-to-peer network to be more secure and more valuable than any other. Like what I mean is, so first, a peer-to-peer network is a network in which there isn't a central computer, like that we talk about, this guy in the middle with the book that he has the truth and everybody needs to ask him. Well, this guy at the end is a server, and there is computer who ask him to see the information that he has. Well, are other computers, is the picture on the left. And what happens, everybody can see good, because I see maybe you cannot see the last part of the slide. Wait, I will fix all this for next lecture. Give me 1 sec. Also, the problem is I see everything that's happening 30 seconds later. Okay, now it's good. So this also makes me slower in handling this thing. I'm gonna be ready next week better, no worries. So what this is the guy in the middle of the room with the book is a server at the end, and the blockchain is a special type of peer-to-peer network, and peer-to-peer network is simply a decentralized network, and we always seen and most probably used peer-to-peer networks. And for example, if somebody used Emule or uTorrent, BitTorrent, these are all peer-to-peer networks, so they are similar in a sense, to blockchain, or at least they have an ingredient. What they are missing is a mechanism of reward. They don't give you cryptocurrency if you put the correct movie with the right title in the network, and this is the reason sometimes You try to download the Titanic, and you get a funny movie, let's say, no? And why it happened? Well, nobody's incentivized to put the right movie, so they put whatever they want with whatever title they want. So this is the reason, no, that blockchain is powerful, because it rewards you to act good. So in a mule made with blockchain, if somebody put I don't know, a porn movie instead of no, Titanic, well, this guy is penalized in a sense. So it kind of makes everybody aligned with the same incentives to work towards the the success, no, of the network. So another piece of the puzzle is users, no? Maybe you say, okay, look, wonderful, blockchain is incredible, but I really don't want to download anything. My computer is already full of things and whatever. No problem. Like you can use, no, cryptocurrency and other blockchain products without necessarily being you, no, a node, without you downloading the software, no, to validate that. Sometimes it's a lot of gigabytes also, and so no problem. What you can do is you download a wallet, no, for example, and I don't know, you buy cryptocurrency somewhere, and you begin to trade it with your wallet. And in this case, you don't need to have a node. Simply, what are you doing in this case is trusting the node of somebody else, which I mean, it's not necessarily a bad thing. It's just you're trusting somebody else. But good thing is that even if you do, you don't need to trust these people, like because if there is the moment in which you don't trust anymore these other guys within the nodes, then you can put your own node, and you are happy. So this is the reason also that discourages, in a sense, a lot of service now to act bad in the blockchain industry. For example, nodes and these kind of things, because at the end, like if you don't trust, you can get your own node. So you have this freedom, no, of choose to trust or not to trust. It's not like you have this guy centralized identity and you need to trust it. If not, you cannot use it. Like here, you can trust, you cannot trust. Like do your own thing, no? Like everybody has different priorities in life. So what is a block? Well, a block is a page of this book that we talked about. It's simply a page. Is a block of information, no? That is the last update of what has happened in the network, in the blockchain. And so yeah, it's like nodes create these blocks to put the information that they see, or the information they create, no, in a sense, if they are active, they make a transaction or whatever. So whatever information they have new between the ends, well, they try to put it in the blockchain. Why? Well, because it's new information. So the network, no, goes. The network goes forward, and the history is updated. So a block is just a page, and this link that connects every block between each other is this cryptographic link that we told now to connect already these pages. So a block is a page. This is what I would like to visualize. And now we go to consensus, which is an incredibly important thing, because this is the thing that makes this possible. Because like without consensus, it would be a chaos. Without consensus, everybody would have different rules, no? Because there isn't a consensus on what are the rules of the network. And if everybody has different rules, well, what happens is that the network is useless, no? Why? Well, because like what can be true for somebody maybe is not true for somebody else. So like it's a real problem, no? This lack of consensus. So, and this is a problem that is made because there isn't a lack of central entity. Let me know if it's too small, in case the writings. I think it's good, but you guys let me know. And also, why is so important the consensus? The consensus is so important because it's really It's really annoying not. Wait, want to try another thing. Give me a sec. Okay, I'm literally tuning it to my screen. Oh, fantastic. Okay, yeah, let me know in case it's bad, and if not, I assume everything is good. The consensus is extremely important because also the choice, no, of but I think it's good now, no? No, if you guys see it, command alt. Yeah, let's see. But I don't want to mess it up. Next time I'm gonna be more prepared. So the consensus is extremely important. The choice that you do, because this will affect how decentralized is your network, how scalable, and how secure it is. And this is known to be the blockchain trilemma. That basically what it means is until a few months ago, it was thought to be kind of impossible to have a blockchain that was decentralized, scalable, and secure at the same moment. And actually, a lot of people would argue that still is the case today. In general, what I would like you to grasp is the fact that your mechanism of consensus is extremely important, because like the way these nodes agrees to some set of rules will make maybe the network more decentralized, more scalable, but maybe a lot less secure. Or maybe it can be a lot decentralized and a lot secure, but is not scalable. For example, Bitcoin, no? Or maybe it can be scalable and secure. Wow, that's the best network ever. Yes, but it's not decentralized. So it says scalable and secure is the guy who has the book in the center, or it's a permission blockchain, no, with very few nodes that can really participate to the network. So the reason I say it's very important the consensus mechanism is because it really affects, no, this where your network is in this triangle. And for this reason also, like sometimes, no, there are different blockchain for different purposes. For different blockchain, I don't mean like nowadays everybody creates a blockchain for whatever reason, but like I mean mostly between the distinction of for example, open blockchain or public blockchain and permission. Like a permission blockchain maybe it's for a completely different purpose than a public one. And now we go to the governance. What is the governance? We said nobody is in charge of the blockchain, so like why are we even speaking about governance? Well, there is some kind of control in the blockchain, but the cool thing is that this kind of control is made by different parties that kind of need to agree in order to use the network. And these parties are, for example, developers, validators. Validators means nodes at the end, and end users. And these three actors, they need to agree on what needs to be done. So if you want to make a very big change in the blockchain, no, that can maybe move the triangle of before somewhere, no, somewhere else. Well, these three people need to be very aligned, no? And why? Well, first of all, if you don't have good developers, like who maintains the blockchain, who updates it, who makes it secure, like of course you can always pay somebody to do it, but like to have extremely skilled developers and extremely motivated is not easy to obtain if your network is crap. Okay, so like in a sense you need to have a project that makes sense to develop. If not, nobody would like to develop it for you. They have other staff or other people that maybe can pay more or it's more entertaining. and without validators, without nodes, well, if the nodes don't agree to some changes, well, the network is not secure anymore. Why? Nobody validates the transaction. Nobody secure the network. Nobody. How can you have a secure network if you don't have this kind of people? So you need to have them to agree to some change, in the code, or that the blockchain is like it is. And then without users, well, it's useless. Let's say, yeah, you have best developer, you have best validators, well, nobody uses your product. Why? Whatever reason, it doesn't matter. But if nobody uses it, what's the purpose, no? At the end. This is very cool, the fact that there are all these kind of actors, between each other that needs to manage to get a bargain, between them, because this is actually what prevents hard forks, which is basically means network split. No, and it's what happened, for example, with it happened a lot of things and a lot of times, but like a cool thing that I remember, it was like when Bitcoin is forked into Bitcoin Cash, like at the beginning. This will covered in another lesson, like more about the history on how the market and how the space it is what it is, and we'll talk more about this, about the Ether DAO and all, Ethereum DAO and all these kind of things. But what I would like to grasp today is that like there was the risk that Bitcoin would have become a lot more centralized because a lot of miners were about to vote for a block increase in size, and this would get Bitcoin a lot more centralized because just very big computer could validate it. And then it was seen that a lot of nodes, a lot of users, and a lot of these people didn't want this. So at the end, a lot of miners that wanted to increase the block size, they didn't do it, and so the network split, and it was seen that Bitcoin is the real Bitcoin, in a sense. So I know it's not easy to grasp this story. That's why we will talk more in the next classes. But what I want to at least get a sense of is that these people, developers, nodes, and users, they need to be together to make some very big change that affects the network, because if not, it's very difficult to do it. So this is a slide that kind of resume whatever we've discussed until now. That at the end, what happens here is so there is a block on the left, and this block has been created by who? Well, so first of all, there was a node, that was this upper one. That's basically what he did is spent some resources that in the case of Bitcoin would be electricity to propose a block. What do you mean to propose a block? Well, simply so there was some transactions, the history needed to be updated. So you say, okay, guys, I have the last state of the blockchain. I saw these things that happen. Let me propose it to you. Let's see if it's coherent with what you guys have seen so far. And these guys, at the end, they say, yeah, look, this is true. This block is correct, and it's actually it's an update on the blockchain. So you know what? This block is correct. So we allow the network to give you cryptocurrency because you spent some resources, to propose this block. And the fact that you spent, you need to be rewarded. Like you really worked, hard for the network. So like it's good if you get rewarded. So you keep behaving good, and so you gain cryptocurrency. So in this way, this is the reason that like why blockchain is secure. Why? Well, it's because like if you spend a lot of electric energy, or spend a lot of money in order to, for example, get so much so much energy that you want to perform a 51% attack on the network of Bitcoin. Like you want to overthrow the network, you want to have your network, the network with your history, your truth. Well, everybody's gonna see it, and when everybody's gonna see it, everybody's gonna realize that the network is worthless because you cheated on it, and you cheated hard because you spent a lot of money, like trying to overthrow the network. Now the network has no value. Congrats, because you spent a lot of resources mining Bitcoin, and instead of doing it to make the network stronger, well, you did it to try to fuck it up. Well, you know what? The currency now is worthless, so you spent a lot of energy like doing nothing. And this is in a small scale, like it's the same thing. Like if you spend some energy and to say your opinion about what do you think is the truth, no, of the network. Well, if you spend this energy, it's better for you to say the truth, because then you get rewarded by the network. If you don't say the truth, they're gonna bust you. Like they're gonna see that you're a fake. So like you simply have lost your resources on top. And what happens? Well, once no, the peers, the nodes, they say, oh wow, you did a very good job, blah blah blah. Well, then no, there is another block. Another node will propose a block. The other one will see that is good, then it's not good, blah blah blah, and then is connected, no, through a cryptographic key, no, every block between each other. And this no way, this is the way that Bitcoin works, no, and a lot of other blockchains. But we're gonna see it a lot more in details how and why it is like this when we will go in the class of Bitcoin, and it's gonna be a class just to understand why it is like this and why it is not in another way. There has been a development, no, an history conceptually also, like to arrive to that. So like we begin to wrap up a bit, like what is blockchain made of? Well, it's a lot of things, and this is also the reason why it's not easy to explain it. It's not easy to understand it at the first glance. It's not easy to understand every piece of it. Is because it's a bunch of ingredients that every of it, like you spend years, no, just investigating on what is it like. So it's made of a consensus protocol, no? Everybody needs to have the same rules, and these rules apply in this network, no? That is made of some nodes, no? It's a peer-to-peer network, so there is nobody that has the central book. There is nobody who can cheat, no, the truth, and it's a peer-to-peer network. Right? Nodes talk between each other. They gossip, no? They broadcast information. There is some game theory, no, and incentives. No, we saw it with when you get cryptocurrency because you made a good job. Well, you're incentivized to behave good. So this is an element also, no, and there is governance. Like there is somebody who has not more power on the network, but simply like as a part on it. Like there is some validators. There is somebody who use it, somebody like every blockchain at the end is different, no, and the way it's done, and in general the governance, like it's in public blockchain, it really relies on the community, no, and the community means it's a community of developers that also, no, is validators, and also they are no, users, but like I say, in every blockchain is different, and but this is important, no, to understand like who is behind, this project, because this will make you also understand if it's trustworthy or not. If maybe somebody like tomorrow change everything, wow, it's tough. And then there is an historial, no, and made by Merkle trees, which is a cryptographic structure that we're gonna see high level in the third lecture, because it's gonna let you understand how these cryptographic keys looks like, how they connect, no, a block to each other. How can you do it? How can you like it's not a link it's like it's cryptography. So we will see how to do it, well, how to understand it. And so now we saw kind of high level, but also we saw a little bit, more some concept on how it is, the blockchain made of. And so now we can make some more precise definitions, no? So before I said blockchain was it's a very inefficient and slow database. Well, is not actually true, in the sense that blockchain is not exactly a decentralized database. It's a decentralized state machine. Like, what does it mean by this? It means that like nodes reach a consent on the state of the network, on the truth of this moment, and they are incentivized to behave honestly, no? Or nodes that behave not honestly, they get penalized. So it's not a decentralized database, or it's not just this, because it actually applies a logic when a transaction is made by a node. So depending on the transaction you made, depending on the interaction you have with the network, then there is a logic that is performed by the consensus mechanism, and then the state of the blockchain, no, gets updated accordingly. So it's not just you put some data in some computer and whatever. Like it's to modify even a small thing, you need to do a transaction, and then according to the consensus mechanism, there is a logic that is performed, and then according to this logic, well, the network gets updated in a way or another. So it's more of a decentralized state machine than a decentralized database. And blockchain at the end is also a technology that allows a peer-to-peer network to act independently, no? What does it mean exactly? Well, there is a cool thing that we're gonna probably mention more when we talk about DAOs, no? Decentralized Autonomous Organization. That is, at the end, for example, Bitcoin, until there is at least one node that is willing to store the code of Bitcoin in his own computer, until just one computer in the world has the code of Bitcoin, Bitcoin exists. Like you can bombard with nukes half of the world. Like if there is a computer in the other half of the world that has not been bombarded, Bitcoin still exists. Bitcoin still survives. Bitcoin still gives a reward to the nodes that try to make it grow and make it more secure. So it's the only way to kill Bitcoin is starving it to death, in a sense. Is making sure that nobody wants to use it. Like that is so crap, so bad that really nobody wants to have its code in your computer. In this way, Bitcoin dies. But otherwise, if there is at least one node, Bitcoin exists, and like Bitcoin, other blockchains. So, no, we saw it's a state machine, it's a peer-to-peer network, it's a decentralized database, and it's an immutable historic of data. No, this is all the things that blockchain is. What blockchain is not, no, because at the end, what is not blockchain? Well, sometimes it is thought that blockchain is a database, no, that just create trust because it exists, no. No, look at this blockchain. It's everything is secure. No, why? Well, how much is decentralized? How much secure is it? No, who governs it? Like, I can create my own blockchain, like now, like while talking with you, and I say, wow, this is blockchain, it's secure. But if the hacker comes in my computer and fuck my system up, well, and it doesn't matter that it's blockchain. Like if it's hosted just in my computer, how can it be secure? How can it be decentralized? How can it... So like at the end, in all these classes, like what I want you to understand, to develop, is a kind of a critical sense on how to understand, like, you know, the different aspects of blockchain, and like why is I have a blockchain is secure, is the no, like let's understand, no, the inner elements of it. And also an interesting thing that is not too intuitive to grasp at first glance is that blockchain is not something that, I don't know, you connect it to a website that say how the weather is today, and you can put the data of the weather on the blockchain like this. No. Why? Well, because if you want to do it, you can, but there needs to be a node that makes a transaction. What it means? There need to be a node that assumes the responsibility to put this data and wrap it in a transaction and put it in the blockchain. Why? Well, because this way you make sure that everybody who makes a transaction at least puts his face in it. Like, not his face, but he puts some stake that if he cheats, well, people no have hey, you made this transaction, like you try to cheat the system. So this means that blockchain needs determinism in order to reach consent. This is not easy to grasp now, I understand. I just want this to begin to boil in your head, because I will need this kind of introduction when we talk about oracles, that are basically centralized systems that cooperate with the blockchain, putting data, no? For example, about the weather, about whatever data you want. But an oracle is a centralized service that gets this responsibility, no? to make transaction about the data that you see. And of course, if somebody see that it cannot be trusted, well, it cannot be trusted. But the oracle makes money out of it to perform, to make good data. And also we're going to analyze the other projects that are networks of oracles, and they get paid because of the data they give, and this is we're going to analyze in some classes from now. And also I would like to give you a glance on what are the different types of blockchain that there are. And so there are public blockchains where everybody can be a node, can participate, and this is the case of Ethereum, this is the case of Bitcoin. And then there are permission blockchain, which yes, you can participate, but if you comply with these things, so maybe you need to tell us who you are, why you want to participate. We will let you know, no? Let's see who you are, and then maybe you can become a validator. Maybe you become a validator, but you cannot validate exactly everything. Maybe you're a validator, but you cannot vote. No, permission blockchains is how Hyperledger does, no? And at the end, is maybe like is needed, for example, if there are different consortium of different companies, for example, and at the end is their objective, and is their willing, no, not to let everybody participate in their network. Like they are enterprise, why they will let a random guy get in the network and begin to say things like, oh, we have our own network, and all these kind of things. And then there is private, no, blockchain, and in this case, like, you really need to be authorized. It's not even that you can ask to participate, like, oh, you're in or you're out, like no middle way. It's not yes but no, like you cannot even see the transactions. Okay, we are getting towards the end, more or less. And it's good to mention what a smart contract is, no? Because it's always, what is a smart contract? Well, blockchain at the end allows for programmable value, no? What it means? It means at the end we saw that the code, no, made through the mechanism of consensus and protected by the history of the network. No, this at the end is code. It's nothing more than code. Well, this code at the end enforce truth, enforce reality, enforce law, in a sense. Not the code is law in this world. And if the code enforce law, well, maybe, just maybe you can program it. You can build your own application on top of Ethereum, for example, and say, look, if this happens, well, then this and this happens. What does it mean? Well, let's say I create an application on top of Ethereum, no? And we'll talk about Ethereum, what is it, and how it works, blah, blah, blah. But I would like to understand now that what you can do is you can program to say, okay, look, when my house reaches the evaluation of 500,000 euros, then automatically sell it, no, to this market or to whoever bids this amount, and use that money already to invest in, I don't know, stocks or buy gold or put it there, blah, blah, blah. Like you can program this. And right now with banks, the only thing that seems you can program is to make a recurrent transfer, which is kind of disappointing, no? Like it's we have a lot of things now. Internet is amazing, and the only thing you can program with money is okay, I pay you every month. This that's a bit sad. Well, so what smart contracts can do? Like, well, they can create real sharing economies. What do you mean by real sharing economy? Well, they don't require an intermediary. They don't require a company that is Airbnb or Uber. They don't require any of this centralized entity to aggregate the service, not that other people offers, because at the end, Uber, Airbnb, they are aggregating economy. They get a database with all the apartments, all the cars of all people, and then they offer this service and they take a stake on it. But like with blockchain, you can build a network where the protocol itself makes this task, and it's not a company, it's not somebody who can do whatever they want, no. And they can allow for decentralized application. They for example, they could allow for a Facebook that does not own your own data, no, but you can still share whatever you like with your privacy. This can be done with smart contracts. And they can allow a thing that is very cool also, that is decentralized finance. So right now it's getting very, very big, the world of decentralized finance. It's called the DeFi as an acronym, and we're gonna talk a lesson just about it, because it's really incredible, all the tools that there are out there, like to hedge the volatility of crypto, to it's incredible. It's really mind-blowing. So it's basically replicating all the what people need in the financial world to put it in a decentralized manner. So like all these things that I've been mentioning is they're all gonna be covered and get all in depth in Cryptonario. And in general, the reason I like to have a contact with you is because also, like, maybe you're interested in knowing something or specific and all these kind of things. So like it's good if you get tuned always, and check the website also, because there is a lot of resources in it that you may like. So next class we're going to talk about what is cryptocurrency. That for now we just get a pixelated of it. A cryptocurrency is a digital native asset, no, where nobody can freeze your account, no, neither banks, neither governments. Monetary policy is written in the code, no, so it's kind of transparent. Like, there is not the Federal Reserve that begins to print all the gold in the world. Like, this is happening now. Like, it's dangerous, no? So monetary policy is written in the code. This can be seen by everybody, and is protected by mathematics, not by banks or governments. What does it mean? Well, it means that the fact that you own this money is not enforced by a bank, that is protected by a government, that is protected by an army, but is protected by mathematics, maths. If you have the key, you are the owner. If you don't have the key, you are not the owner. And this allows you that you have the freedom that nobody can freeze your account. You have real financial sovereignty. This is the power of it. And the next class we're going to talk about cryptocurrency, on Tuesday at 7. And in general, I would really suggest, if you are interested in even a very small slice of what I've been talking about today, check also the resources in the website of Cryptonario, because there is really a lot of things, also news on economics, if you are interested. And if you didn't do, I would suggest you to subscribe to Cryptonario. In the home, you scroll all down, not because I want to spam you, because it's really the last thing I want to do today, but it's because in general you get like content that other people don't get, and also you get some information logistic about the class. So in general, I think it's good if you subscribe. And so now it's open to questions. So I'm happy to hear some question about whatever I've been told, King, or other things. So I see we're 24. It's very nice to have you here, and I suggest, if you liked this class, then like join the next ones, and also like tell other people that may be interested, because next class is gonna be cryptocurrency. Thank you, Patrick, and thank you all of you, like, for assisting. Like, it's nice to see this support. And so, like, share no the links and of the website, and you're gonna find a lot of interesting things, and let people join, because this world is changing fast and it's good to be tuned. And like I think it's good when things are for free and it's a lot of good knowledge. So like let people know about this. So yeah, if you have any question, like you can write in the chat now, and I will give you few minutes. And if I see there is no question, well, we see you directly next week. Okay. Well, I think all good. Either way, like in the next classes, thank you to all of you. In the next classes, you can ask also question. You can write email also, and check out the website, the resources, and tell your friends or people who are interested. And thank you for your support. And we're gonna see good things in this website. So keep tuned. Big hug to everybody.